Let's look at a few more examples then. So suppose we have A and not B. Sorry, let's say we have A and not B, and we want to convert that into an expression that uses only NOR gates. Well, first step is always just to write out again exactly the same thing, and then have a think about which of the rules you can apply. Remember, there were two rules. The first rule was that we can add two lines anywhere we want, as long as they're the same length. I mean, we can't add a short line and a long line. So two short lines, one above the other, fine. Two long lines above a whole expression, fine. So rule one, we can add two lines. It's worth mentioning also that we can cancel out two lines. So that's kind of rule 1B, if you like. So you can add two lines or cancel out two lines as long as they're the same length. And the other rule was break a line if you change the sign. Or we can break a line as long as we change the sign. So here, in order to make this from NOR gates, it's rule 2. We're going to break the line and change the sign. So breaking this line, changing this sign, gives us this. So because we've followed the rules, this is exactly the same as this. But we're not finished yet because this uses OR gates, not NOR gates. And we're looking to build it. We want to do a conversion, if you like, to all NOR. So the next thing we're going to have to do is add two lines. So this is the same as this, and if we add two lines across the top, then the plus symbol and the lower of the two lines represents a NOR gate, and the top line is an inverter, as are the other three. And of course we can cancel out these two short ones if we like. So actually, if I draw that out again, we can simply cancel out these two. So now we have something which is built with all NOR gates, and because we've followed the rules, it will do the same thing. I'm just going to draw this out again, but this time colouring the NOR gate part a different colour, just to remind you what's what. So here in this pink colour we've got the NOR gate plus symbol with a line above it. This short black line is an inverter, and the black line across the top is also an inverter. So we started off with this, which looks like this. Two inputs, A, B. B has an inverter on it. And then both of them go into a NAND gate. And our task was to create a circuit which does the same thing but uses only NOR gates, and we've arrived at this. So let's take a look at how this looks. A is through an inverter, and then I'm going to draw the NOR gate in that same colour just so that you can tie them together. So not A, nor B. And then through a final inverter. I'll just change the colour of that line. We've got a final inverter here. And remember, we can actually make those two inverters using NOR gates themselves. So we could, it looks the same on the Boolean expression, whether you create it using a real inverter, or whether you create it using a NOR gate or a NAND gate wired up as an inverter. There's no different symbol over here. So we end up with that. And this circuit will do the same job as this circuit, except this is built with only one type of component, in this case a NOR gate.